Mr. Harris here, and welcome to another video of Unit 9. In this video, we're going to talk about simple molecular structures. So simple molecular structures, it has to deal with covalent compounds. Some examples of covalent compounds we have learned are nitrogen, oxygen, halogens in group 7, which are all diatomic. Diatomic means they're diatomic molecules. It means there are two atoms. So for example, in group 7 we have F2 fluorine, Cl2 chlorine, I2 iodine. You may ask me, why are they diatomic? The reason is because they want to obtain or achieve a stable electronic arrangement. So some other examples of simple molecular structures are ammonia, water, and carbon dioxide. So most of the nonmetals, they indeed have simple molecular structures. So let's get into the details of what simple molecular structures are. So simple molecular substances, they have strong covalent bonds within each molecule. So within each molecule, there are strong covalent bonds. So I would like to emphasize one word: within each molecule. Okay, I would like to emphasize within each molecule, there are strong covalent bonds. However, let me use green. However, among or between, another word that I like to use is between. Among or between bromine molecules, there is a presence of a weak attractive force. And this weak attractive force is this one over here, the ones that are dotted over here. Okay, I'm just gonna color a few so you understand what I'm saying. So between bromine molecules, or among bromine molecules, there is a weak attractive force called van der Waals forces. And this is weak, unlike the strong covalent bonds. So let me use another example. So let's have a look at iodine. Iodine is a black solid at room temperature. So it contains within, notice the word I'm using, within iodine molecules, there are strong covalent bonds. However, among or between, let me use blue, among or between, so the ones that are shaded over here on the right, these are what we call weak van der Waals forces. Okay, so the name of this force is quite interesting. Actually, it's named after a person, as you can imagine, van der Waals. I think he's from the Netherlands, if I'm not mistaken. And you will notice that you need to keep the W over here capital, and there should be apostrophe towards the end of the S. Okay? And another word that we usually associate van der Waals force is the word weak. Now you may ask me, sir, how weak is it? So it's pretty weak. so weak that, for example, iodine at room temperature, as I mentioned, is solid. And if you just apply a very small amount of heat, it would immediately become vapor. So just a small amount of heat is enough to overcome the weak van der Waals force. So let me show you another example. We have carbon dioxide molecule over here. So within carbon dioxide molecule, there is strong covalent bond. Okay, S dot C dot B is a short form for strong covalent bond. However, let me use another color, among or between the carbon dioxide molecules, there is weak van der Waals force. Okay, and this is a picture of dry ice for those of you that are interested. Okay, now let's talk a bit about the properties of simple molecular structures. So the first property that we've also talked about giant ionic structures are melting boiling points, the physical state, the solubility, and finally we'll talk about the electrical conductivity. So based on the data given over here, it's easy to notice that the melting and boiling points of these simple molecular substances is low, and usually at room temperature and pressure they are gases or liquids, except for iodine. I'll talk about this in a while. They're slightly soluble in water, not really soluble. And finally, they're non-conductors, so they do not conduct electricity. So just a quick summary. So simple molecular substances, they're usually gases or liquids. However, if they are solids, they are soft in nature. We'll see the explanations of all of these in a minute. These substances, they have low melting and boiling points. They're slightly soluble or even insoluble in water. However, they're soluble in non-aqueous solvents. Non-aqueous solvents. I'll come to that in a while as well. And finally, they do not conduct electricity. They're not electrical conductors. So let's talk about the physical state. So, for example, iodine, it's solid. However, it's soft. So any simple molecular substance that is a solid, they're usually soft. The reason behind is due to the van der Waals force again. So this van der Waals force is again weak. So it's a weak attractive force. So it's very, very simple to break the solid. Same reason of why it's a low melting and boiling point. Due to the presence of the weak van der Waals force, a very small amount of heat is needed to overcome this weak attractive force. Hence why most of the substances are liquids or gas at room temperature. Iodine is a solid at room temperature and pressure. However, when a small amount of heat is applied, it immediately becomes vapor, iodine vapor. And the reason is because of the weak van der Waals force. So for solubility, as I mentioned earlier, simple molecular substances are usually soluble in non-aqueous solvents. So what does it mean by non-aqueous? So just by the name, you can guess that something that does not have water in it. Okay, so one example is cyclohexane. Cyclohexane is an organic solvent, so it's a non-aqueous solvent. And if you put iodine in it, it's the diagram on the left, you'll see that the iodine is soluble. However, if you put iodine in water, you will notice that it's not really soluble, it's just slightly soluble. Or in this diagram, it might be difficult to say that, so we might even say that it's insoluble. Okay? And for electrical conductivity, simple molecular substances, they do not conduct electricity. The reason behind is they do not have mobile ions and they do not have delocalized electrons. Okay, let's look at one example to consolidate our learning. So you can pause the video and do the questions by yourself first, and then we'll come back to these. Neon and oxygen are elements in the same period of the periodic table. Question 8. Draw electron diagrams for neon and oxygen. Notice the word they use is molecules. So draw electron diagrams for molecules of neon and oxygen, showing electrons in all shells, so not only the outermost shell. So let's go ahead. So neon molecule is just Ne. However, for oxygen molecule, it is O2. Now, why isn't it Ne2? Or why isn't it O only? Now, the reason why is because Ne by itself, it has 8 outermost shell electrons. 8 outermost shell electrons, so it has a stable configuration. So we will not add anything else. However, if we just have one oxygen atom, I'm just going to draw the outermost shell electron. It has 6 outermost shell electrons. So does not have a stable configuration. It is not stable. So hence why oxygen molecule, it exists as O2, so that there are 8 outermost shell electrons. Question B. Name the attractive force that exists among oxygen molecules. So notice the word they use is among, or sometimes between. So what is the attractive force among or between oxygen molecules? Yes, it is weak van der Waals forces. Finally, let's look at question C. The boiling points of neon and oxygen are listed below. Explain why the boiling point of oxygen is higher than that of neon. So let's have a look. So neon, it exists as a monatomic molecule, so only one atom. However, oxygen exists as a diatomic molecule, so 2 atoms. This is 1 atom. Hence, oxygen molecule has a larger size than a neon molecule. So oxygen has a larger size, so when comparatively, stronger van der Waals force would exist among oxygen molecules. Okay, so even though, generally speaking, van der Waals forces is weak, but when we're comparing between 2 simple molecular substances, we can compare which one has a stronger or weaker van der Waals force. So the one that has a larger size would have stronger van der Waals force. Okay? So just to summarize today's video, so for simple molecular substances, the physical state is usually gases or liquid at room temperature, and the melting and boiling point is low. And what is the reason for these two? Yes, due to the weak van der Waals force. How about the conductivity? Yes, they do not conduct electricity because no mobile ions and no delocalized electrons. That's why it's a non-conductor. And how about for solubility? It is soluble in non-aqueous solvent. However, it is slightly or insoluble in aqueous solvent. Okay, so there you have it. This was a quick video on simple molecular structure. So make sure you've watched the previous videos, giant ionic structure as well. And then in the next video, I'll talk about the giant covalent structure, which is also existing for covalent compounds. Okay, make sure you've subscribed to the channel. I'll see you in the next one. Bye.